If you recall, we have been solving oblique triangles with our new tool set. The sum of the angles is equal to 180 degrees. That was always in effect. But we had to get rid of the Pythagorean theorem because we're solving oblique triangles. We don't have a right angle, so we don't have a hypotenuse. So that's out. We also couldn't use the opposite adjacent hypotenuse versions because once again, with no right angle, there's no hypotenuse. So we had to replace our tool set with the sum of the angles is 180 degrees, the law of cosines, and the law of sine. For the most part, we just had to use whatever one we could to get for our fourth piece of information. And we have to worry about one extra thing. Here's the case where we have that extra thing. It's the law of sines, the ambiguous case, and it's the two triangles. So the ambiguous case of the law of sines happens when you're going to use the law of sines first, and you have one angle. So that's the ambiguous case. You only got one angle, and you've got the side opposite that given angle, and then some other side. We talked about the conditions and the number of triangles that each of those conditions produces. If you would recall, we'll have a given angle, we'll have a side opposite the given angle, and what we've called the other given side. And it's the side opposite the given angle that determines the number of triangles. If the side opposite the given angle is less than the height, then you have no triangles. You draw an angle with your given angle and the other given side, and the side opposite the given angle is too short to connect the other given side to the line where the third side is supposed to be. You get one right triangle if the side opposite the given angle is exactly equal to the height. If the side opposite the given angle is greater than the height, but less than the other given side, that's the two triangles case. And if the side opposite the given angle is greater than the other given side, then you're back to the one triangle case. The important thing to note is that we can determine the number of triangles by computing the height and comparing the side opposite the given angle to the height or the other given side, and determine what case we're in. But we don't have to know this going in, as long as we recognize there's a possibility of having two triangles. Let's see what condition we have here. So in this case, we have the, I need my calculating machine for this. So in this case, I have an angle of 30 degrees. Side B is 10 and side A is 6. So I am going to use the law of sines because I have an angle alpha and I have the side A. I have a set of opposite parts, A and alpha. I notice that the first thing I'm going to do is the law of sine because I have that set of opposite parts. And the first thing I'm going to be looking for is an angle. So I know that we're in the ambiguous case of the law of sines. The first thing we're going for is an angle, and we're using the law of sines to get it. That's the ambiguous case. That means this is on the table. If we want to know, if we want the spoiler going in, then we can just calculate the height. The height of this triangle will be the other given side, in this case 10, times the sine of the given angle. In this case, 30 degrees. Sine of 30 is a half, so 10 times the sine of 30 is 10 times a half, so the height is 5. We see that the side opposite the given angle, 6, is greater than the 5, so we have at least one triangle, but it's less than the other given side, so that means we have two triangles. Since the side opposite the given angle, 6, is greater than the height, but less than the other given side, we know we're going to have two triangles. Our strategy for dealing with the two triangles is to take that first angle that we find and put it in the second quadrant as well. That's where our two triangles come from. Once we know we're in the two triangles case, put the first angle that you find into the first and second quadrants. That's how we split the problem into two triangles. We take that first angle that we find and we put it in quadrant 1 and quadrant 2. So we got to find our first angle. It's going to be, our first angle is beta because I have alpha and A, and I have side B. So that means we're going to have to find angle beta. So sine alpha over A is sine beta over B. Alpha is 30 degrees. So the sine of 30 degrees divided by 6 is equal to the sine of beta that we're looking for over B, which is 10. So I'll multiply both sides by 10 and take the sine inverse to find angle beta. So I do 10 times the sine of 30, close parentheses, and then divide by 6. And that'll be my first angle beta. So I'll take the sine inverse, oops, make sure I'm in degrees, of 10 times the sine of 30, that's just the height of the triangle, and divide by the other given side, the side opposite the given angle. So it looks like beta is 56.4 degrees. We know that we're in the two triangles case here. So we have to take this angle. That's going to be our quadrant 1 angle. So on one side, I'm going to say here's beta of 56.4 degrees. That's our quadrant 1. But then I have another beta that I got to put in quadrant 2. So 180 minus 56.4 is 123.6. So I have two different values of theta representing our two different triangles. So this is how we split into the two triangles case. Okay. Now I have to solve both triangles. At this point on the left, I have a beta of 56.4 and an alpha of 30. As soon as we have two angles, we subtract to find our third angle. So in this column, gamma is 180 minus the 30 minus 56.4. And that's going to be 93.6. So I've got my first beta, my first gamma. Once I have a gamma of 93.6, I can use the law of sines again to solve for C. I want to use as much given information as possible. So I'm going to use sine of alpha over A equals sine gamma over C. So that means that sine of 30 over 6 is equal to sine of 93.6 over C. So I'll multiply both sides by C and then divide by sine of 30 over 6. So C is 6 times the sine of 93.6 divided by the sine of 30. So 11.97. So the 7 pushes the 9 up to the next, so 12.0. That's one of my triangles. I've got the given alpha, B, and A, and now I have the found beta, gamma, and C. So over on the right column, I have a beta of 123.6. Once we have two angles, we subtract to find the third angle. So gamma, our other gamma is going to be 180 minus 30 minus 123.6. So that gives me a 26.4 degree angle for our other gamma. Then I'll do the same thing, but instead of using 93.6 for gamma, I'll use 26.4 for gamma. So I'll say sine of 30 over over 6 is sine of 26.4 over C. C is going to be 6 times the sine of 26.4 divided by the sine of 30. We can draw a picture of what is going on with these two triangles. Remember what happens when we have the two triangles case, when the side opposite the given angle is greater than the height, but less than the other given side. If I draw down here the side where the third side goes, I have my other given side forming the given angle. Here's our height. Of 5. And there's two places that I could put a side opposite the 30 degree angle that's 6 units long. One of them will make an angle of beta. So here's B up here. And here's alpha. One made an angle of beta opposite the side B of 56.4 degrees. That's drawing it over here. Or I could take that 6-unit side and swing it around to the other side of the 5, because the 6 is still less than 10. And that's making this angle, this version of beta, at 123.6. So those are the two angles that we get right off the bat. Quadrant 1 version and the quadrant 2 version. When beta was the 123.6, notice that made side C shorter. So with this beta of 123.6, that gave us this length for side C. So that would be 5.3 down here. But with the beta of 56.4, that gave us this length for C. And that one was 12. So there are our two values of C in our two triangles. Because we could take that side opposite the given angle of 6 and swing it between two sides, or make two different triangles. We got at least one triangle because the 6 was bigger than the height of the triangle at 5. But since it was less than the 10, that's what allowed us to swing it back and forth and make those two triangles. How's everybody okay? Okay, looks super stoked. Awesome, two triangles. So one thing to keep in mind is that in this case, we figured out that there were going to be two triangles. That's why we put that first angle into the two different quadrants. It could be that we forget to do that step. We don't bother checking the heights. Maybe we don't even notice the side opposite the given angle is greater than the other given side. And we try to proceed in a two triangles form when there's only going to be one triangle. So let's look at a variation of this. What if we don't notice that it's not a two triangles case? So let's suppose we don't notice it's only one triangle. Let's suppose that, for example, I have an alpha of 30 degrees. Side B is 10. And now side A is going to be greater than the other given side. And we're just not even going to notice that. So A is going to be 12. So here's our given angle. A is our side opposite the given angle. and B is our other given side. In this case, we're going to have one triangle because the side opposite the given angle is greater than the other given side. So I'm not going to be able to swing it back and forth and make two triangles. If I swing it to one side, I get one triangle, but then I swing it to the other side and it goes all the way around because it bypasses that other given side completely. So we're going to pretend that we didn't notice that. The side opposite the given angle was greater than the other given side. There's only going to be one triangle. But let's suppose that we are going to notice that we are in the ambiguous case of the law of sines. We're about to use the law of sines to find an angle, and it's the first thing that we're doing in the problem. Therefore, it's ambiguous case, so we might be thinking, what if there's two triangles? So sine alpha over A is sine beta over B. So let's see, sine of 30 degrees over 12 is sine beta over 10. So beta is sine inverse of 10 sine 30 divided by 12. Even though we know that 10 sine 30 is the height of the triangle, it's 5. And we were given another chance to look at the 12 and say that's bigger than our other given side. So we're going to go sine inverse 10 sine 30 divided by 12. So beta is 24.6. Once again, we're pretending that we know we're in the ambiguous case, but we didn't notice that there's only going to be one triangle. And we're going to do our two triangles thing. Because if you get an angle for beta, just automatically put it into the second quadrant. So our beta in the first quadrant is going to be 24.6. And our quadrant 2 beta is going to be 180 minus 24.6. $155.4. So we split these, we still haven't noticed that this is not two triangles case. Now that on either side we have two angles, we automatically subtract to find the third angle. Once you have two angles, you subtract to find the third angle. So in this case, gamma is going to be 180 minus 30 minus 24.6. $125.4. And then we're going to find side C. So we'll take the sine of 30 over 12 is a sine of 125.4 over C. So C is 12 sine of 125.4 divided by the sine of 30. $19.6, and we're done with this one. Now we go over onto the other side and say, now I've got to deal with this other beta of 155.4. The first thing we should do is, since we have two angles, is subtract to find the third angle. So our second gamma will be 180 minus 30 minus 155.4. And now we can see how the numbers are going to tell us that this was the one triangle case. Because now when we subtract, we get a negative value for gamma, and that can't happen. So we're done. We do 180 minus 30 minus 155.4, negative 5.4 degrees. Here the numbers are telling us that this was just one triangle. There is no second triangle. So we don't bother with this beta. We just go back and cross that out. I say, whoops, didn't need to put that in the second quadrant. Just like before, when we had the zero triangles case, the numbers will tell you when there's no triangle. Because you'll try to do the sine inverse on that as that first step, but the side opposite the given angle is less than the height. This law of sines is trying to find the sine inverse of some number that's bigger than 1. So you get an error. And you interpret that as being no triangle. You go back and check the height and say, oh, look, my side opposite the given angle was less than the height. There was no triangle. I did a bunch of extra calculations. The best part is like on a written exam when you erase that part. I'm not going to be able to see that. So you're like, oh, I don't want him to see that I'm going to take off points because you did that. You know what I mean? It's like on a test or something like that, when something comes up and you like go over and say, oh wait, what's 13 times 7? You go 13 times 7 is 21. And you do it in this old messed up way, right? Because it's a habit. If this is the fastest way for you to multiply, because you don't have a calculator, first of all, it's a trigonometry class. You should have a calculator. What the hell is going on? Second of all, if you just go over here and do this 7 times, 91, right? So everything's cool. Then my favorite move that students do is they write this on the side of their test, and then what do? You hide the evidence. You go and erase it. Like, I'm going to take off points because you did 13 times 7. Like, I'm going to say, what are you doing over here? What is this? I'm going to circle and say, well, how could you be messing your paper up with this multiplication? You should be doing that in your mind. It's like, I don't know. And second of all, when you erase it, you're just demonstrating that you feel shame, and you shouldn't. You know what I mean? It's ridiculous. It's this weird reaction. I don't know where you got that from. I don't know who hurt you in your mathematical past that you feel like you have to erase. Like, oh, don't be embarrassed. Just write it down. If you need to write it down, just write it down. Wow, I was thinking I didn't have time to reach over to my calculator. Hang on a second. Maybe 13 times 7. Oh, good, I did it right. But you do it all, but students do it all the time. Then they'll erase it. As if I can't see that you erased something there. Like, it's not like you clicked on it and deleted it. It's not like you photoshopped it out. You just erased it. And I could totally see what was written there. I was messing with a student once on their test. They were erasing all their marks. So I put a big red circle around it. It's like, oh, I saw that. Minus 10 points. And I'm like, oh, what? And then on the next page, I'm just kidding. Ha ha. And then as they were walking out, they're like, oh, Leach, that wasn't funny. And I was like, oh, incorrect. It was very funny. Just not for you. You know what I mean? So this is the great thing about the ambiguous case of the law of sines. You have to be aware when you are in this situation. And you just take that first angle you find and put it in the second quadrant. If it's only going to be one triangle, the numbers will let you know that it's only one triangle. If there's going to be two triangles, the numbers will let you know that there's two triangles available, because you'll be able to continue. If you're in this situation where the side opposite the given angle is less than the height, and you don't check the height beforehand, don't worry, the numbers will let you know. If I put A is equal to 4, then the first thing that we would do here is we try to do the sine inverse of 10 times the sine of 30 divided by 4. and it would give us an error. And at that point, we would say, hang on a second, did I do that right? And you say, yeah, side opposite, the other given side is 10, the given angle is 30, the side opposite the given angle is 4. Then you realize, oh, that's right. 4 is less than the height of this triangle, therefore no triangle. So I'm done. So that's the overview for your law of sines, the ambiguous case. This only happens if the first thing you're going for is an angle and you're using the law of sines to get it. If you're using the law of cosines, you don't have to get your first angle. This is not a consideration. You've already got all 3 sides. Law of cosine. Let's talk about it later. So, hey, did you already do the law of cosine? It's like, well, yeah, we did that last week. And I'm like, oh, man. But then they heard me say law of cosine. Generalized Pythagorean theorem. Any questions? So you don't have to, it's only when you're using the law of sines and you're going for an angle first. The other situation where you're using the law of sines first is when the problem has 2 angles at the start. In which case, the first thing you're using is not the law of sines, you're subtracting to find the 3rd angle. And so at that point, you've already established that there is 1 triangle. It's only in this case. The first thing that you're looking for is an angle and you're using the law of sines to get it. That's the ambiguous case. Put that first angle you find in the first and second quadrant, just in case there's 2 triangles. Is everybody okay? I'm sure you all look very sad. Mixed emotion time for last week. We're heading up. See, they're happy about it. It's not the last week, it's the last month. Oh, see, now they're pissed. Now they're pissed. Oh, you said the last week and now you changed the month. Look at the last month. I was wrong. So on one hand, yeah, it's the last month, we're almost done. On the other hand, oh no, it's the last month and we're almost done. All right. All that's left to do now is y'all to practice solving triangles. So this happens in chapter 7, solving oblique triangles. There's some other stuff in chapter 7, but right now I want you practicing on solving oblique triangles. Are there any questions? Comments? Yeah, that one's the solving equations. That one goes way back. But because I forgot to put due dates on things, it kind of like, I was like, oh, I didn't want them to be due like right after I put due dates on them, because then it looks like I messed up. But then, so these ones, I'm just going to put a due date of the last day of the semester. So anything that shows up now is going to have a due date of the last day of the semester. You should keep in mind that that is going to be, the homework gets cut off at that point. So anything that gets a due date of December 9th, that's not only the due date, that's the cutoff date. So on December 10th, if you still have assignments to do, the song assignments aren't getting done. So you're just gonna have to let those go. Also, any assignment that doesn't get a due date, I'm probably not gonna, I'm actually not, I'm just gonna say, I'm not gonna grade. Even if I just forgot to give it a due date at the end of like December 10th rolls around, I go, hey, I never put a due date on section 7.4. That's just on me. Any questions? There are going to be more quizzes though, so you can look forward to that. Yay. That's how you react to quizzes, right? Like, yay, more quizzes. Is that how it goes? I don't know. I don't really remember being a student. It was a long time ago. All right. That's going to do it for today. I will see you all on Thursday. We'll begin talking about our very last topic, which is super cool and one of my favorites. Everybody have a good couple of days, and I'll see you on Thursday, and thanks for playing.